Hello, my name is Mateus. I'm from Team Snacks, and today I will present to you the current status of the schedule of the project. So, for these 2 weeks, we plan a total of 155 hours, and we spent 105 hours until today. We are 0 hours late and 0 hours in advance, so our balance is 0, so the project is currently on schedule. I would like to note that in our current schedule, we have 3 tasks in progress. However, this is not a problem for us because our week 4 in the schedule only ends on October 18th. So we have 1 day to finish this task uh, to keep the project on schedule. So we will follow the deliverables for this week. So for this deliverable, we will show you the mechanical structure of the vending machine and the test of the electronics in the next video. So here we can see a quick demonstration of the motion system moving the product dispensers in the vertical and horizontal axis. Additionally, we have a video showing the product dispenser working, delivering a snack to the user.
Now we will present the software design. We have created 2 use case diagrams. This one shows the interactions between the parent and the mobile application. The use cases identified are create account, login, register a child, set snack options, set budget, register a payment method, view child order history, unblock an account, and block an account. The other use case diagram shows the interactions between the child and the vending machine and the manager and the vending machine. So the 2 actors of this diagram are the child and the manager. The child use cases are buy snack, that includes choose snack, confirm snack, and collect a snack, and authenticate, that includes use NFC tag and choose image. The manager use case identified is update products stock, that includes choose product and set product stock. In addition, 4 activity diagrams were created, taking into account the use case diagrams. This diagram shows the parent authentication activity in the mobile application. So when the app is opened, the parent can choose to register or to log in. If chosen to register, the system shows the create account screen. The parent enters the username and password. The system validates and saves the data and shows the login screen. That is the same screen that the system shows if the parent chooses the login option. After the system shows the login screen, the parent enters the username and password. If it's a valid user, the system shows the home screen. Otherwise, the system shows the login screen again. This diagram shows the activities that parents can perform while browsing the app. So after the parent goes through the authentication activity and gets to the home screen, the parent can choose between registering a child and selecting a child. If the parent chooses to register a child, the register child activity, the parent provides the child information, associates the tag number, and selects a password image. If a child is selected, the parent can lock or unblock a child account, set snack options by setting the availability of each snack, register payment method by providing payment information, set budget by setting the maximum amount to be spent in a day, and view child order history. This diagram shows the activity of buying snacks carried out by the child. So the child uses an NFC tag to authenticate, and if the tag is recognized, the child selects the password image. If the image is incorrect, the child selects the password image one more time, and if the image is incorrect again, the activity ends. If the correct image is selected, the child chooses a snack, then cancel to choose another snack, or confirm to collect the snack. This diagram shows the activity carried out by the stock manager to update a product's stock. The manager uses an NFC tag with administration privilege to authenticate. If the tag is recognized, the manager choose a product, and set the product stock.
The mobile app was designed on Figma, where we built this prototype with an app navigation example. First, the app starts on the login screen, where you can log in with an existing account or create a new account. While creating an account, you need to view your desired email address and set a password. If the account registration is successful, you will be redirected to the home screen. Currently, there are no children registered, so let's register one pressing the Register Child button. On this screen, you have to fill your child's name and NFC tag value, and also choose a password image to be used on the vending machine. After saving, you need to choose the allowed budget and snacks for the child you just registered. After saving, you will return to the home screen where you can check how much each child has spent. By pressing on a child card, you can manage their account. You can view the account's order history, edit the allowed budget and snacks, and view their account details. On this screen, you can also delete the child account.
The vending machine software was designed separating the pages into 3 categories. First, the login authentication pages. Second, the order pages. And last, the response pages. The application starts at the NFC authentication page. As the user, you need to place your tag in the sensor to proceed to the next step of the two authentication factor. The next step is the image authentication page, in which you have to choose your correct password image. In case you fail to do so, you will be directed to the failed authentication page, where your only option is the Go Back button that leads you back to the first page. If you pick the correct image, you will be directed to the product selection page. This page showcases the snacks available for purchase as well as your current credit available. There is also a Go Back button in case you give up on the idea of buying snacks. That button will redirect you to the first page. In case you press on a snack, the next page you'll be directed is the product selected page, containing the snack you chose, as well as how much credit you will have after the purchase. In case you want to pick another snack, you can do so by clicking on the Go Back button to go back to the product selection page. If you want to proceed with the purchase, you have to click on the Confirm button. That will prompt you with the order processing page. This page tells you to wait until the vending machine's motion system delivers your snack. Once everything is done, the page displayed on the screen will be the order finished page. This page gives you two options, the purchase again and the option to exit. If you click the purchase again button, you'll be directed to the product selection page and you won't need to authenticate yourself again. If you click the exit button, you'll be directed back to the first page, the NFC authentication page, where another user can begin their own process of buying a snack. In case there is any error in the order processing step, the user will be prompted with the order error page that allows them to go back to the product selection page to restart their order.
An entity relationship diagram was created to understand how different elements within the system interact and relate to one another. In our model, the entities are parents, children, child snack orders, child allowed snacks, password groups, and images. This was done in a way that the requirements we set previously are all met, such as the requirement for the children to be only allowed certain snacks and the requirement for the children password to be done through a selection of images. The relationship between children and child allowed snacks is crucial to ensuring that children only have access to permitted snacks. The relationships in the diagram are also done in a proper logic. For example, password groups and images are an M to M relationship, as one image can be associated with more than one group, and one group will have 6 images. In conclusion, by following this diagram, we are going to be able to provide children an easy way to acquire snacks while providing parents control over what their children consume.
So for the cloud server, we created a documentation regards the architecture that will be used to implement the software. The purpose of this document is to describe the high-level architecture of the backend server for our project. So it includes the folder structure, component organization, technologies used, and key design decisions. So one decision that we've made is to use Docker for maintaining consistent environments throughout the development process and when deploying to the production server also. And additionally, we've agreed to utilize a server provided by one of our team members for hosting the application. Well, uh, this is the class diagram from the vending machine's motion system software. At its core, it features a main class, which aggregates two key components, a WebSocket controller. This object is responsible for facilitating communication with the motion system controller, obtaining input from the vending machine UI. Meanwhile, the motion system controller oversees the vending machine's movements, employing 2 instances of the reflectance sensor and 5 to 7 instances of the limiter switch class. The sensors enable precise motor positioning, and for the motor control, the system utilizes instances of the A4988 driver and the ULN 2003 driver, both of which implement the stepper driver abstract class. Uh, Now, I will present the state diagram of the vending machine system with an overview of the system behavior. Uh, the system initiates in a state of waiting for child, where it waits for input. And when an NFC tag number is read, the system check its validity and check if it is blocked or not. And only if the tag is valid, the system progresses to the next state. So it transitions to the authenticating state, where the child selects their password image. And if the chosen image does not match the correct password, the child is granted another attempt to authenticate. And after 2 wrong attempts, the child account is blocked and the system enters the handling error state. And it displays an error message to the child. However, if the child successfully provides the correct password, the system advances for the next state, which is the waiting for selection, where it waits for the child to select a snack. And if the child selects a snack and has enough budget to buy it, the system moves to the waiting for confirmation state. In this state, the child can choose to proceed with the purchase or to go back to the previous state. And if the child confirms the purchase, the system transitions to the providing product state. And if no errors arise, the child receives the snack and the system resets, ready for a new process. And in the event of an error, the machine reverts to the handling error state, where it displays the issue to the user.
So, this is all we have for this deliverable. Thank you for your attention.